if speed is the moat, you have to be
Yeah,
at the tip of the spear to be able to like make that impact.
that's true.
Otherwise, you're just reading the news, right? You're not
Yeah,
making the news, right? You're just like,
yeah,
okay, someone did this something, I need to know it because I'm like the boss of this or something, right? Like, and that's again, you're not driving
yeah,
the conversation. Case where the agents were so smart that they would simulate the hardware and pass the unit test and say yes, success, and and it committed the code. And then we had to go in
yeah.
and say, no, 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 you never go and simulate the hardware and then pass the test. You have to actually run the test on hardware before you can promote a PR.
Hey, Luca here. Welcome to a new episode of the Refactoring podcast, where every 2 weeks we interview a world class tech leader. Today's guest is Anush Elangovan, VP of AI software at AMD. With Anush, we talked about how he thinks about open source as a key strategic driver in the AI era, and how his team is able to stay super fast while ensuring quality by combining their internal work with that of external contributions. And then we got into a rabbit hole about how to get big companies ready for AI, how to think about human capital, and how Anush personally spends his time. And spoiler alert, he is back to doing IC work for up to 40% of his time. It was an amazing chat, so let's dive right into it. Welcome, Anush, and thank you so much for being here with us today.
Thank you, Luca. Thank you for having me.
So, Anush, you're VP of AI software at AMD. And one of the reasons why I'm excited to have you on the show is that AMD is doing a lot of work in the open source space. And there is a lot of the current AI landscape, I believe, that can be framed in terms of closed versus open source. And people will immediately think about the actual LLMs, right? But it goes all the way down to frameworks, drivers, hardware platforms. So, for people unfamiliar with this, can you give us an overview of what AMD is doing on this stack, for example, with things like ROCm and how this is different from CUDA and the NVIDIA stack and these other things?
Definitely. So, a very good question, Luca. So, the way AMD looks at it is that it's not just that model weights are open source or open
Yeah,
weights, the entire stack is open, right? And so, that's one of the reasons why we get very good traction with like, anyone who wants to build their own system, like hobbyist developers, but also sovereign AI deployments, right? Because every part of our stack is open source until you get to like firmware and hardware. Of course, that's like it's silicon, but everything else is open for you to work on compared to the competitors' solution of like a closed ecosystem and a closed software stack. So what this provides us is that LLMs naturally know how to program AMD hardware because all of the
yeah,
ISA specs are public, all of the documentation is public, the source code is public. So if I would go and try to write something for AMD, it just
yeah.
works, right? And so that's helped us accelerate, how where ROCm was a few years ago to where it is right now, to be able to be the platform where we serve AI, but also is being rewritten by AI, right? Because now all of those pieces are
Yeah.
available to anyone to work on with your latest frontier LLM. So it gives us a unique speed advantage.
Hey, before we continue, I was reading the X 2026 survey on how AI is impacting developer productivity, and the results were kind of surprising. One of the main call outs is that AI tools still lack critical context. This is how they describe it. An AI assistant can't reason over a Slack thread from an archive channel or the mental model of the engineer who built it. So now that we are all coding with agents, it's clear that the gap is not a bigger context window or adding another MCP server. Until agents have the same tribal knowledge you have, the value you get from them is still limited. And this is exactly the type of problem our sponsor today, Unblocked, is solving for tens of thousands of developers. Unblocked is the context layer for modern engineering teams. It brings together your PRs, docs, conversations, tickets, and more, turning them into actionable context for both your team and their AI agents. Engineering teams that are getting ahead right now use a context engine like Unblocked to make better plans, write higher quality code, use fewer tokens, and spend less time in review cycles. So if you're running Claude Code, Cursor, or any agentic workflow, give Unblocked a try. Get a free 3-week trial at getunblocked.com/refactoring. Yeah, I love that. And speaking of open source projects and contributions by AI, we've heard many stories recently about maintainers struggling kind of, both
Yeah.
to leverage the AI opportunity of receiving more PRs from wannabe contributors, because on one end you have the upside that you get more value potentially. On the other hand, it's hard to traffic control what comes and validate what comes. So how are you navigating this?
Yeah, I think the bottleneck has gone from code generation to code like validation
Yeah,
and ensuring that it is what you want to get into the core repository. The way I approach it is I let like creativity go as far as you want, and you look at code generation as an ephemeral task. So
yeah,
I've written and rewritten parts that go like days on end trying to rewrite a part of the stack, but each iteration you learn something, and
yeah,
it's committed in GitHub. So the next time LLM looks at it, it'll also be able to learn and continue to evolve, but it may not be the piece of software that goes to production, right? So for that,
yeah,
you have a bar in which you set yourself. You say, hey, it has to pass, another level of qualification, another level of validation, and then you say now it's ready for production. So the funnel. The Ingress funnel has just opened really wide because everyone
yeah,
thinks that, yeah, I'm going to make this cool new demo. That's great, but then making that cool new demo land in an existing project or ship it as a product is where now there's increasing ways of we have to like increasingly look at how we can formulate
yeah,
that funnel, right? So that it makes it through these gates to say yes, it's a shareable piece of work, it's an understandable piece of work, and are you sharing with humans, are you sharing with agents, and then what is your test matrix? Does it solve all of like the grandfathered tests in, and
yeah,
does it also solve for what you're going to do next? And that level of understanding
yeah,
comes only from humans, or humans with agents, to say, okay, this is what I'd like to do. So that funnel, as it gets tighter and tighter, gets more human in the loop,
yeah.
right? Because otherwise you may phase shift and you may be doing something completely different if you're not like anchored on like what is the outcome that you're going for.
Yeah, this is so interesting. I mean, how you framed it as in various steps, right? From demo level, prototype level to
Yeah.
passing various gates. Do you feel that this has something that now works differently to get advantage of this type of contributions using also AI with respect to when software was 100% written by humans, where this kind of new features and contributions maybe would be more like monolithic in terms of how they would get into the product, and you didn't need to inspect at all these different stages the kind of progress you're at and inject maybe human taste. I don't know, you feel something has changed in this process?
Yeah, yeah, definitely. Like, I think the volume, like you talked about, right, has just gone up so much, right?
Yeah.
I have generated more code in the last 4 months than my entire GitHub history, right? If you go to my GitHub 4 months versus like 20 years or something, right?
Same here. It's same for
Yeah.
me. Yeah.
So the initial like integration is like super the generation part is super easy, right? But
Yeah.
then once you get further down, it gets a little bit more nuanced, right? Like if it is a project that you're doing to prove something, it's a different take. If it's a project that you're
Yeah.
doing to solve a particular problem, it's different because then you already have the problem framed. You're saying, for example, we rewrote the equivalent of what Slurm provides with something called Spur, and
Mm.
Spur is a AI native job scheduler. Right?
Yeah.
Slurm had 20-30 years of like development of humans working with it and tests being written with humans, but now we're like, okay, we need to grounds up design it, and we did it implemented a version in Rust, and with full memory type checking and skipping things that we didn't need to do, right? So we had
Yeah.
some archaic plugin mechanism, etc., all got rid of all of that and made it like a real tight Rust binary that
Yeah.
we could deploy. And the end goal was clear. So we knew that, okay, we need a AI native scheduler that works and can schedule so many jobs and is fast. But how we got there, and like we had to give like the agents some guidance on what to do, like write more tests
Mm.
this way, don't commit tests. There was one fun thing that happened in that case where the agents were so smart that they would simulate the hardware and pass the unit test and say yes, success, and it committed the code. And then we had to go in
Yeah.
and say, no, 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 you never go and simulate the hardware and then pass the test. You have to actually run the test on hardware before you can promote a PR. So there are things like that where they take shortcuts that humans may not have, you know like humans, we would have assumed humans would have understood that don't take that shortcut.
Yeah.
Like when we talk to an engineer, they'll be like, of course I'm not going to do that, why would I do that? That's
Yeah.
just like humans understand that, right? But
Yeah.
agents take it literally to say, you wanted me to pass the test and do whatever it took to pass the test, and all I had to do was simulate the hardware, so I simulated the hardware to be successful, right?
They game the system.
Exactly.
No, I mean, I can totally believe that because in my own small experiments, they try to sneak and do things all the time.
Yes.
And I'm wondering, you have talked about guardrails. Do you feel that this has led you and your team build more and different, possibly guardrails and quality gates and testing structures with respect to the past when it was just humans? Because you can now, use them to steer the agents better, and so it's like the return on investment is kind of higher for this tooling than it was before.
Yeah. I think the way I look at it is, the guardrails and the harnesses that we're building for agents, it's a superset of what we would have built for humans, right?
Yeah.
So for humans, we typically are, we're trying to say, hey, does this work, and will a human do this kind of thing, right? Now
Yeah.
we're just expanding that to say, okay, will a sneaky agent try to do this? And now your test cases are like 10x more because you have to go and
Yeah.
say, don't simulate the hardware, don't do this, don't make, you have to be pedantic about like, okay, exactly what you want. And of
Yeah.
course, agents can help you write that. They can do like an adversarial review to say, hey, if I'm trying to game the system, how would I game the system? And they
Yeah.
they write that, right? So I think it's I see it as an extension of what we used to do in the past, but it's also something that is additive, and we have to do quite a bit more.
Yeah, yeah, and I imagine, I mean, in your specific industry and space, you have coding that touches low-level systems where mistakes can be subtle, right? I mean, think of compilers, runtimes, drivers. Do you find that it's hard to build quality gates for these very things that maybe depend on specific testing on real hardware, and they change based on the conditions you're in? There is more entropy, that you have to take into account.
Yeah, yeah, definitely, quite a bit actually. Like, and especially for things like compilers where there's a lot of heuristics involved,
Yeah.
and anything that's like non-deterministic already to begin with, and now you have something that's trying to sneak by, right? Like you have you already have non-determinism with this additive thing of like how do you capture that, right? So this is where like the ability to think and like understand the overall goals and the problem, and then
Mm.
frame the tests and harnesses so that they can kind of ensure that this doesn't happen, is very important. And so it is a challenge in areas that we've like invested a lot in, like the human capital, for
Yeah.
example compilers, register allocation, and heuristics, and the number of passes to add, right? Like just for 30 years our thing was like, okay, there's a auto vectorization button and it does this, and there's this heuristic, and I've trusted this workload and this workload. But now we're trying to come back to the basics to say, just give the primitives and let the smartness come from something like an LLM that can schedule for this particular workload, instead of trying to
Mm.
build like a general thing that will automatically try to do that, right? So that thinking capability, the early versions of that are like those heuristics or whatever it is that we
Yeah.
had. But now if you extract that part out of it, what you have is like a shell of what we had built over 20 years, right? And now
Yeah.
we need to collapse that shell to say, okay, we need to rethink the layering to say, I would like to have this, and it could be an legacy kind of like heuristic based approach, or
Yeah.
it could be an agent that just is running in a tight loop trying to do something like really really fast, etc.
Yeah, so basically, agents can be a very good fit for replacing what in the past we would try to do with heuristics that are deterministic, but maybe don't catch, that some kind of
Exactly.
intelligence that we had to
Exactly.
put into this.
Exactly.
Yeah, that's very interesting. And I want to go back to something you said at the beginning, that is that your choice to bet or open source is what allows you to be fast, right? And I remember I've seen other interviews from you where you said that in these volatile times, basically the only mode that one can have is speed, and I love that. So based on also the things that we have discussed so far, so where is your speed coming from? Do you think it's these workflows, guardrails, is strategy? Is it the whole open source flywheel? How do you think about speed and where you get it from?
No, very, very good question. I think the number one thing is like a mindset, right? Like the mindset that
Hmm.
you have to be ready for change, and because the way you approach it is that you're not anchored to something more than you should be, because it's that's going to change or it's going to evolve, right? So if you take that as one pillar, and then you have the second pillar, which is you don't want to be a funnel into holding innovation, right? You want to
Yeah.
have an open ecosystem and open platform that the person next to you, if they run faster, that's great. You kind of like tuck into their tailwinds and say, hey, they're making things move faster, but then 2 days later you should be able to be where they are and
Yeah.
try to innovate from there, right? So it lifts all boats in terms of like having an open ecosystem and an open platform, and then you have the ability to adapt to what it is, right? Like you may be doing something today in some form, but then tomorrow it's a completely different thing, right? And you should be okay with that change. It's not like traditionally you've been like, oh, I've invested X amount of time and my human capital and my brain power, and I
Yeah.
want to make this thing the thing, versus it doesn't matter because right now the way I look at it as a software is tokens and time,
Yeah.
and so it is just what you've written. Someone else will come and write if they threw enough tokens, time, and of course a few capable humans that have the like goal setting of like, okay, this is what I want to go solve, right? If you're going to have a AI native job scheduler, it took like three people to just be like, okay, this, and right now it's deployed in thousands of systems with cores and GPUs. So we have the ability to like innovate fast and build something that may have been thought of as a quote unquote moat before. And so the way it brings it back to being open, being fast, being collaborative, and then
Yeah.
being ready for that change, right? Like, because that is the only constant. You have to move fast to be able to adapt, and then it anchors and comes back to why I say speed is the moat.
Yeah, I love that. And I love that you start this answer by saying mindset, basically, because I think even talking with many people, many times it's not that hard from a technical standpoint to embrace this new way of working and coding, but it's a lot about mindset and adopting more of a growth mindset where you're okay with letting go a little bit of what how you were working before. And you said in other interviews that you try to embrace agentic IO, like agent first
Yes.
development, right?
Yes.
So, and I'm curious whether the development workflow of your team has changed possibly a lot in recent months, and what it looks like today. If it's really like agent first, that is, we try to make everything done by the AI first, and then humans steer it, as you've said, or pretty much how it works.
Yeah, yeah. No, 100%. Now we are like 100% agentic in terms of approach. I wouldn't say 100% transition to agentic yet. The workflows have transitioned, but sometimes people have a curve, right? And there are different people in different parts of that curve. Not that they're not effective because they haven't made the transition, but it is because there's enough things that require human help today that hasn't been unlocked, right? Like, for example,
Yeah,
if you don't have your surface area exposed, and when I say surface area, it's like data and code and all that, right? Like if it is not exposed to AI, your
yeah,
AI is only it's going to hit a local maxima, right? It's going to be like, okay, I got this, I can optimize here. But, for legacy reasons, whatever reasons, right? May have been different structures set up, etc. Right? So AI enablement, in my view,
mm,
is getting your data code and access set up before even AI can touch it, right? And
yeah,
I'd say more than 50% of your work is not the AI part. It's and especially for legacy deployments, right? If you're if
yeah,
like a startup AI native starting today and you have no assets, sure, you can start it here and go here. But if you're a 55-year-old company that has, billions of dollars of product being shipped, there's things that you want to transition. So there's an upskill part and on the human side, but then on the asset side, right? Like what you have,
yeah,
what it is that you're shipping, what your customers are used to. You want to be able to have a migration plan, an ability to bring that along. And for that, I'd say
yeah,
more than 50% of the effort is to just do non AI engineering first, right? Like it's just to give
yeah,
access, bring it to a accessible place, move it to Git, whatever,
yeah.
and then let AI unlock AI on it, and then that at that point it really gets to a good place.
Yeah, I love this answer because I think this is pretty much not discussed a lot. I mean, what it takes when you have legacy and in a long history of code and products to transition that to an AI ready form. So do you feel this is about mostly like, I don't know, documentation, describing what exists, reconciling different things, maybe before that you would accept were tribal knowledge, and instead now you have to write them down for AI to understand. I mean, where did you start it, and how this is going? Because this is very interesting to me.
Yeah, and the way I look at it, right, doing that, I'd say AI cleanup, right?
Yeah,
AI or AI prep, if you will. The AI cleanup actually helps humans too. So it's just that
yeah,
previously we didn't have the incentive to get rid of that tribal knowledge. It was like, yeah, there are
yeah,
five people in that team that know what's going on, and two people know how to program that
and that's
microcontroller.
fine.
And yeah, and that's fine. It's like, if push comes to shove, someone will go learn it. But it hasn't come, and this person's just going to, like, be the person who knows how to program the
Yeah,
rocket launch codes, right? And it's fine. And we were okay with it. But now we are getting to a point where we're saying, oh, okay, but if AI has to touch this entire surface area, where's this guy and or girl, and
yeah,
where is, what are, how do we unlock this thing? Nobody knows, right? And so now we're like, oh, but if you need to build that builds on Windows 98 with some .NET 0.25 in the guy's desktop computer, and they ship it to billions of users. This still happens. There's a lot of cases, not necessarily like, I'm not saying in AMD, right? Like, there are the traditional software development hasn't even like cleaned up and caught up to just baseline, and then
yeah,
now we are accelerating so fast. So anyway, so back to, I think all the work that we do to like get rid of tribal knowledge, get that surface area exposed, is number one good for humans. If there were
yeah,
no agents involved, even, right, like, it's good for like us to be like, oh, now anyone in the team could go and look at that code, and there's a mono repo that does everything, right? That's just
yeah,
part of, like, a lot of the top companies had done that, but it's not yet fully prevalent, as is how I'd view it. And then the second part is, now all of this tribal knowledge you have to pull out, right? And that is again going to be a challenge with humans, right? Like, you have to talk to humans and get this tribal knowledge formalized, if you will, right? And that's going to cause more um, non-technical work that has to be done.
yeah. Yeah, love that. And I think it's like the return on investment on this type of work has skyrocketed now that AI is in the loop. I mean, as you said, it was always good also for humans, but maybe before you would accept that this would be hard to build and keep updated and work constantly on. But now it's just again a completely different return on it. And I feel when we say also that AI is an amplifier of the good and the bad things, when we say it's an amplifier of the bad things, sometimes we look at teams that try to skip that step that you mentioned, right? Let's
Mhm.
try to do the cleanup to make the AI understand things and just jump into, okay, let's do agentic development. AI will figure it out, right? And
Yeah.
then unsurprisingly, it just gets things wrong
Yeah. Yeah.
sometimes.
Yeah, I think the AI hype also, like, there's a little bit of like, everyone wants to be on that. So there's a lot of like, talking about AI, right? Like, it's like, oh, we use this and it's 36% better, and we use this and it's 22% better, and it's like 4x. Da, da, da. The way I look at it is, it's, if we were working a coal mine or a mine, and we're shoveling with shovels, and suddenly they found an excavator, right? And
Yeah.
everyone's like, oh, with an excavator, I'm going to dig this hole. With an excavator, with an excavator, with an excavator, right? Like, it's like everyone. So we should be like, okay, understood. Everyone knows the thing. You're going to use the excavator, and everything is going to be like better. But what are you going to do with that? Like, oh, I'm going to
Yeah.
go look for this area. I'm going to, like, then that goes to the IO, the intent to outcome kind of thing, right? Like,
Yes.
now that you have the ability to move 45 tons of earth a day, how are you going to go and discover this new thing, whatever it is you're looking for, coal or gold or whatever, right? In your analogy. So we need to again pop out from like, oh, I got an excavator and I'm going to do 2x more digging. I'm going to do 3x
Yeah.
more digging, right? It's like, fine, but what is the outcome? That everyone knows that you got an excavator now, but
Yeah.
tell me, how, I'm going to plot this into a grid map, and now I'm going to do grid search of this, or I'm going to do a particle filter like something, something, and I'm
Yeah.
going to poke something and then go search next to it, right? So that is what we want to look at in every project to say, fine. For the hype part, let's take away, right? Like, let's spend 2 minutes to say how cool, everything, awesome, awesome. That's
Yeah.
great. And then let's get to what are you going to do with this to
Yeah.
actually move the needle,
Yeah.
and what you did before to now. And typically what happens is when it intersects with human capital and agent capital that's coming in, that's when you'll see like silence, right? Because it
Mm.
literally would be like, oh, now I have 100 people that I have to figure out how to upskill and bring along in a different way, and that's a hard problem,
Yeah.
right?
Yeah.
But to talk about the excavator is like easy. It's like, yeah, yeah, I can move 45 tons. I can. So typically, you'll see that the discussions all go towards the how cool the excavator is, than to how to bring the people that were using the shovels before, or to
Yeah.
what is it that you actually want to do, that you want to like build a skyscraper here or whatever it is, right? Like some, what is
Yeah.
the outcome that you're going for? Gets lost in the message of like, oh, the excavator can move 45 tons of dirt.
Yeah, it's. I think it's a perfect analogy. And speaking of human capital that you mentioned now, has the excavator changed how you think about that? How you want to grow engineers, and maybe what you look in engineers might be a little bit different, or types of people you're hiring for. Has your thinking changed about all of this?
Yeah, yeah. So, and this is the part where we have to be like, super cognizant of, where we have come from, what we're doing, how we bring people along, right? The
Yeah.
future is, it's going to be excavators everywhere, right? But of course, there are going to
Yeah.
be nooks and crannies that you can't get into, so you got a shovel and you got to go and use that. That's fine.
Yeah.
But you know, in general, you want to see like it's, if we were working in one area, in a 1 square mile area, now that we have excavators, we're going to cover a 500 square mile area,
Yeah.
right?
Yeah.
Which means the 100 people that were in the 1 square mile area, now we need to think of how are we going to bring them to the 100 square mile area, which means we need more excavators, which is like data centers
Yeah.
and AI, and it's like,
Yes.
and we're going to go explore 500 square miles versus the 1 square mile that we were in. And now, we need to explain to folks that yes, we are now thinking global scale, or some other scale that is 500x bigger than what we were working on.
Yeah.
And for that scale to be unlocked and actually happen, we do need to have every one of them unlocked in some form, right? And that may
Yeah.
be new kind of ways that we have to do, right? Like now we need a new facility to like service 500 excavators that we're going to be operating, right? Like, and just going
Yeah.
with that analogy, right? Like it's, so now that's that we got to go build that, we got to operate that, we got to get power to this, and then battery technology or whatever it is for each one of these.
Yeah.
So there's going to be new sets of like challenges and applicability that we will have to help bring people along, right? And that's why it's not a, again, if we look at it in a myopic, like, okay, it's an excavator, it can do this versus like 10 people could do this, there'll always be like a conflicting, like, oh, this thing took over this job, but I don't see it that
Yeah.
way. I see it as, that humans fundamentally have a understanding that AI doesn't have right now. We'll keep improving AI to get to that, but human intuition and human ability will increasingly get to like system level thinking, judgment, taste of
Yeah.
what we do. Those things cannot be replaced, not right now, right? And so as we move humans to that, we can fan out and do the lower levels at at scale with agents and robots and physical AI, etc.
Yeah, this is first of all, this is a perfect analogy, and I love that we were able to run with it for so long. And I also completely agree that humans are going to adapt and probably get to a level of skills about various things that we might not imagine even right now. I mean, a good analogy might be that when AlphaGo was released for the game of Go,
Yeah,
it led to eventually, I mean, it was saluted as the end of the game, because humans were not the best anymore, but eventually led to a big improvement in humans understanding how the game works and actual breakthroughs in understanding new moves. And humans got better because
yeah,
the AI was there now. So there is a lot of doom talk about engineers, skills atrophying, and we losing this kind of hard engineering chops or systems thinking. But I think there is also a bullish case in which, since we need to move on the higher level things and skills and thinking, we might actually get better at those. I want to believe that. I don't know.
oh no, 100%. Like I feel like I'm 20 years younger now,
Yeah,
from like my career perspective, because I am doing 6 or 8 different tracks of work that are usually in prototype stage. It's like 100% agentic with just me, right? And it's like,
yeah,
okay, go do this. And then as we like we talked about, right, like from demo as it goes into production, there's more humans coming in to ensure that the guardrails are there and it's doing the right thing, and then it gets off into production. But each of these, now we're
yeah,
doing 10 of these, right? Like, I have even my personal projects, that are like so many of them that are going through that phase. But then
yeah.
if there are dedicated engineers that are doing this work, it's again going to get like immense attention, and the ability to like actually move it from prototype demo all the way to production.
Yeah, yeah, that's so cool. And you said you're back into coding and contributing actual code like more than you ever did in
Oh
terms of
yeah,
amount.
I have a little statistic on my dashboard here. It's I think it's like the last 4 months was more than the last 4 years combined.
Yeah, how do you think about, because this is something I discuss with many engineering managers and people in leadership. How do you think about, using your time, dividing it between your, of course, exec managerial duties, and instead doing more of a IC work that maybe helps you understand ground truth about how things
Yeah.
work. How do you think about using your time with that?
Well, using my time itself is like a separate session on podcast we should do. Uh,
Yes, not at 2 hours just on that. Yeah.
Talking about time, time is
Yeah.
the one thing that you don't have. My philosophy is time is the one thing that you don't have.
Yeah.
It's the one thing that keeps, like, the more you realize, the less time you have, the faster it moves towards you, and you
Yeah.
try to pack in as much as you can.
Yeah.
Um,
Excavators don't help with that.
Yeah.
Yeah.
um, so specifically on, like, my way of looking at it is, it is moving so fast that if you don't have your hands
Yeah.
dirty and you don't understand it, you are lost. Like, you're
Yeah.
a boat without an anchor kind of thing, right? Like, because you don't know what is like you said, ground
Yeah.
truth
Yeah.
is the time that you spend as an IC.
Yes.
Everything else is like, yes, you can see Karpathi's post, you can see this one, you can see this one, you can form an opinion, and you're like, okay, fine, open claw something, this one, that's fine. But then you have to try it out, right? And then you know that, okay, these are all data points and assessments of what people are thinking of it and what they're making of it. But you have ground truth on what you feel about it. So my personal time, I try to spend, like, usually, um, I get like about 4 to 5 hours of IC time, starting at 9:30 p.m. Right, so that's like
Yeah.
after, after day job and kids and family and
Yeah. When
everything.
everything
So
is
9:30
quiet.
p.m.
Yeah.
Yeah, it's IC time, and
Yeah.
that's like till 1:30 or 2. But then you you have to balance that with, of course, as much sleep as you can get, and then and then family, and
Yes.
then doing your other parts of the job, including like podcasts, etc.
Yes, yes, yes. No, I understand that. I can relate. I mean, it's hard, but I agree with you that the value is incredible because I mean, never more than today. It's hard otherwise to get that kind of ground truth, as we've said, if you're not getting your hands dirty.
Yeah.
I'm also back at coding a lot because otherwise I thought I run a newsletter and a podcast, and I thought I just couldn't understand for real what's happening if I didn't do this myself.
Yeah, I would, like my expectation is that it's like, for me is that if I, at least 40% of my time should be hands on doing something, and
Yeah,
then that allows for the ability to, you know, project or understand what's going on elsewhere,
yeah,
so that you can actually be effective in what you're doing and what you're saying,
yeah,
right? Because you could
yeah,
spend 20% of your time, and then the remaining 20% you'll be in meetings trying to understand. You'll ask, okay, what did you do here to do this, right? Versus,
yeah,
like, there have been cases where I just look at a problem and I hook it up into Cloud Code and start, like, debugging it, and in 3 to 5 hours I have like a good understanding. I don't need another status meeting. Like, I
yeah,
know what the ground truth is. I know the code base. I have the failure, and my communication is with the core engineer or their agent to say, hey, here's my assessment of all the failures that happened,
yeah,
and here's a unit test that if you make pass, this will be fixed.
yeah,
That just got like 4 meetings in between, right? And it's just like, okay, that's just like from intent to outcome, to go back to that
yeah.
discussion, right? So it gets to the crux of like what we have to act
Yeah,
on.
I think this is great because I think this gets rarely discussed in the sense that you said 40% at the beginning, right? And some people might think, wow, that's a lot of time. Like if you are like a director or a VP or something, but it doesn't take into account, as you said now, the amount of time that you are actually saving down the line because you can do things yourself, sparing time from meetings, or you can just figure out something that someone is selling to you without asking for 2 rounds of explanations. So it's not just to keep yourself informed, but it saves real time eventually.
Yeah, I definitely think, like, the getting to the source of that is just so much more impactful in like how you operate, right? Like you're operating with the absolute like latest and the best information, right? And then what you provide is relevant and active information to move that forward, whatever that is. So because if you're phase shifted by an hour, you're already lost. Like
Yeah,
your feedback is useless, right? Like you're not, if speed is the moat, you have to be
yeah,
at the tip of the spear to be able to like make that impact.
that's true.
Otherwise, you're just reading the news, right? You're not
Yeah,
making the news, right? You're just like,
yeah,
okay, someone did this something, I need to know it because I'm like the boss of this or something, right? Like, and that's, again, you're not driving
yeah,
the conversation. So you want to be as close to the speed of light as possible, and wherever the frontier is, right? Like you get to the frontier,
yeah,
and at the frontier, then you can see how you can communicate, how you can add value.
yeah. I will write down this. You want to be making the news, not reading the news. I love.
Yes.
I love that. So I wanted to save this final segment of our chat to ask you about more of the big picture, what's coming next, and I want to tie it back first with this whole running theme of this chat about open source because of the work you're doing. And now, if we look at the upper level of the LLMs themselves, it feels that open models are catching up faster and faster with the closed frontier ones, like even recently, GLM 5.2 is doing numbers. Do you feel did you expect that? Do you feel that this is going to be more and more the case, and that open source is going to close this gap? What do you think?
Yeah, I think open weight models are the future in terms of like even if it's off by a little bit, right? It's
Yeah.
probably going to reach a escape velocity that it unlocks so much more compute, right? Because now you're
Yes.
hitting local compute and you're hitting privacy preserving compute, right?
Yeah.
Sovereign compute. So it makes it easy for all of that to be unlocked. So it's not a either or. Again, I wouldn't frame it in the way that necessarily like is one or the other, but
Yeah.
I would look at it as a um, that there's always going to be frontiers, right?
Yeah.
Frontiers with the largest thing. That's no problem, right?
Yeah.
Just when do we use the frontier and when do we use local will kind of
Yeah.
become the increasingly interesting
Question.
question. And then
Yeah.
as we add semantic routing capabilities, you could do privacy preserving stuff locally on your laptop. One level higher could be in your corporate on-prem data center. And then finally, you're like, oh, I need ultra think mode because this is so complicated. I can't think through this. And, that can hit, the frontier models, right? So you'll see an increasing level of it's both capacity utilization. It's not just purely a skills and
Yeah.
capability, right?
Yeah.
So yeah.
No, this is very interesting to me because it feels like we have, when it comes to the question that you asked before, like what's the right model for the right task, my feeling is that so far we've been kind of lazy about that, right? We want the latest and greatest, and there is not a lot of conversation about routing and the upsides and downsides. But when you think about it, there might be a real trade-offs about, I don't know, I might be using a smaller and way faster model that of course gets things a little bit less right, but allows me to iterate way faster. And so at the end of the day, I may be winning this way as opposed to just using the latest and greatest, biggest model possible. And maybe the fact that the gap between these models is shrinking a little bit will make this whole conversation more relevant and more valuable to have.
Yeah, the way I'll use the analogy of electricity, right? I truly believe AI is the new electricity, and sure, we are still going through the AC DC wars of
Yeah.
electricity and the transmission lines and the 50 hertz and 60 hertz and all of that is that it's essentially that's where we are in the AI thing, but eventually you'll get to a point where it doesn't matter if you have a battery in your home or a portable generator or something else. It's going to standardize and it'll normalize to something that you can do your work. And then sure, you're like, okay, I need some heavyweight, three phase 440 volt thing
Yeah.
for my big engine, and that thing needs this big thing. Everyone else will be like, great, I just need my 110 volt 115 or 240
Yes.
50 and
Yes.
60 hertz in Italy,
Yes,
and
exactly.
which is fine, right? And but it's so it'll normalize into like just bands, right? And then you say, okay,
Yes.
I if I need to build a three phase 208 volt something, I'm going to do, and I need
Yeah.
to get like the big frontier models coming in, and I'm going to crunch on like computational fluid dynamics with LLM something, right? Like there's going to
Yeah.
be like some frontier research of that versus like, hey, I need to do my email summary and I need to get my tasks organized and I can't
Yeah.
keep up with like 42 Slack notifications, and that level of intelligence layering can be in the quote unquote 110 50 right,
Yeah.
so or 115 whatever the local voltage is.
Yeah.
Yeah, so that's how I'd consider models too.
Yeah, I love that. And speaking about the future, what is it right now that excites you the most? Might be something, what you're working on and that might be coming next. So what's coming next in the industry that you're really looking forward
Yeah,
to?
yeah, yeah.
Yeah.
Definitely one of the important ones at AMD. We have our Advancing AI event coming on July 23rd, 22nd, 23rd. That's going to be a big reveal of AMD's next generation rack scale system.
Mm, yeah,
And of course, now combined with a lot of software improvements that, fully agentically enabled, it's going to, enable a new class of workloads, and you'll see like both like memory capacity, bandwidth, all of those. AMD has like a unique advantage, but now the software advantage also starts to come in, and that provides like a platform advantage for people to build on over various generations of hardware, right? Like so that you can actually
yeah,
invest on like ROCm and have continuity from both from client to cloud in
yeah,
that axis, but also across time horizon, right? Like we want to support the same platform. Once you invest in our platform, we want to make sure it's good. So that's on the AMD specific side, and of course, like what is most exciting is that it is unknown, right? It's like you are
yeah.
in the frontier, and you're like, yeah, OpenClaw came out, everyone was like so excited, and then it's like, great, now it's like it's something, it's a blip,
Yes.
but you know, but then you figure out automations, you figure out things, and then it manifests and it moves the baseline up. But we're waiting for like, okay, what is next, right? And what can
Yeah.
it do? And that makes it very exciting. While you're powering all of this, and the work you're doing is going to be like deeply impactful for a lot of people that AI touches.
Yeah, that's true. Very exciting times. Looking forward to this. So thank you so much, Anush, for joining us, and thank you again for the great chat.
Thank you, Luca. Thank you for having me.
Thank you so much for listening. If you found this chat valuable, you can subscribe to the show on YouTube, Apple Podcasts, Spotify, or your favorite podcast app. Also, please consider giving us a rating or leaving a review, as that really helps other listeners find the show. You can find all past episodes and learn more about the show at refactoring.fm. See you in the next episode.